Every chemical process plant requires pumps and compressors for fluids to flow, and hundreds, if not thousands of valves to modulate the flow and other applications, although they are hardly given credit for what they do. This is why they are our true hidden heroes. Although a place they are acknowledged are in the piping and instrumentation diagrams, also known as PNIDs. PNIDs are visual mapping provided as schematics that display equipment like pumps and compressors, control systems like sensors and valves, and relevant piping. Every chemical process plant requires a PNID. In a chemical process plant, they work as the universal language between engineers and operators. Engineers rely on these diagrams for HAZOP safety studies, maintenance planning, and commissioning. Without a PNID, we cannot build, operate, or safely shut down a chemical facility. This is a PNID of a sulfuric acid production facility, where pumps, compressors, and valves are identified with these symbols. For better clarity, it is beneficial to check the legend located at the bottom right of the PNID, as well as the lead sheet that is provided with PNIDs.
Now, as we look into how valves and pumps look in the PNID diagram, we can see what they truly are. For a valve, we will look into the angle-seated valve as well as how to assemble it.
Angle seat valves are manual valves which are used to modulate or shut down flow. They open or close when the plug is moved linearly to the C-axis. According to Charles Kolstad from Tameson, this type of valve is usually found in pharmaceutical manufacturing, specifically for fluid and gas control, where efficient flow control is critical, wastewater treatment, as they can deal with sludge, proving their resistance to clogging, and harsh environments in chemical processing plants, where durability is required. Nevertheless, the angled path results in higher resistance, leading to unwanted pressure drops in the pipe, and which are detrimental for high flow systems.
Before starting the assembly, make sure to put on your lab coat, safety goggles, and tie your hair back.
This is all the equipment you will need. Start by connecting the screw-in part to the extension. Screw the extension into the housing and secure it with the union nut. Attach the spindle to the screw-in part firmly and add the handwheel to the spindle. Secure the handwheel in place using the washer followed by the hexagonal nut. Finish by securing the spindle in place with the threaded pins using an Allen wrench. And then spin the spindle to lock it in place. Spin the handwheel to open and close the valve. Now we will be looking at the centrifugal pump.
Centrifugal pumps use a rotating impeller to throw liquid outwards, converting mechanical energy into high-velocity kinetic energy. This is then transformed into pressure energy by the pump's casing, forcing liquids out at a higher pressure than what was entered. They are the standard choice for constantly flowing liquids at high flow rates. Therefore, they are used across all industries, for example, oil and gas, water and wastewater management, chemical processing plants, and pharmaceuticals. Although they are the standard choice, centrifugal pumps do struggle with unsteady flow and viscous fluids.
This is all the equipment you will need. We start by securing the spiral housing with sealing plugs with flat seal while simultaneously inserting the shaft to the shaft bearing block. We then secure a bearing cover at the inner side of the bearing block and secure it with hexagon head screws. Follow it by placing the splash ring in the middle of the shaft. We then assemble the packing gland by placing a packing, then the locking ring followed by 3 packings into the housing cover, then securing the press on top of it using hexagonal nuts with washers. It is to be noted that due to technical issues, the shaft sleeve could not be placed on the shaft. This does not disregard the general assembly procedure. We then attach the packing gland to the bearing block and firmly set the impeller on the packing gland. Attach the hexagonal cap spring with spring ring to the shaft. Then place the flat seal on the bearing block and attach the configured bearing block to the spiral housing. Secure it with hexagonal nuts. And finally, place our second bearing cover on the outer side of the bearing block and secure it with hexagon head screws.
Thank you for watching.